Hey, this is the third part of combining like terms. And for me, this is it right here. This is the wrap it all together. What is the point of combining like terms? Well, when we get into combining like terms with equations, that's another story. But this part right here is great because what I'm going to show you for example number 1 and 2, what you're going to do when we get to unit 6, we're going to do this so much when we graph. We've got to know how to do this because this is going to speed stuff up. All right, let's just flat out say I'm going for it. I'm going to evaluate -3 times the sum of x and 6 plus 8x. What if I just plugged in, what if I just did it, Mr. V? What if I just go for it? What if I go 3 times x plus 6 plus 8x? What if I just plug it in? I don't know, man, you're kind of crazy. Well, I'm in. We'll do this together. -3 times, well, I'm going to put that in for x just for a minute, plus 8 times whatever x is. I always like to start the parentheses first. So you're going to see y next in the next one. You're going to love y. For x, I'm going to plug in -12. -12. Here we go. Order of operations. We do what's inside of the grouping symbols first. Well, that's just 8 times -12. Who really cares? And this is -12 plus 6. Got negatives, mixing with positives. Stuff's going to cancel. We're going to subtract then. 12 minus 6, because I've got 12 negatives and I've got 6 positives. So the positives are taking away from the negatives. So everything else, though, is going to get written the same. This is going to be written the same. That I'm not doing yet. I'm just doing what is inside of the grouping symbols first. I'm going to take a moment. I'm going to say, this is happening first. Nothing else is changing. What's inside is first. So, -12 plus 6, well, there are more negatives than positives, so the negatives will win. And since the negatives are being taken away by the positives, 12 minus 6 is 6. So we get -6. So these turn into these. That was because of the grouping symbol. By the way, let's rock the balance line. Now, I'm going to take -3 and -6, and I'm going to say, well, negative times a negative is a positive, and 3 times 6 is 18. I'm going to multiply all at one time, so I'm going to bring that plus down. I'm going to say a positive times a negative is a negative, and 8 times 12 is 84. I think so. Do you? I think so. $18 is positive, -84 is negative. There are more negatives than positives. So that means the negatives have this huge bank of 84, and 18 is taking away from that. Those positives are taken away from the negatives. So, well, here we go. 4 minus 8, can't take that away technically. So I got to borrow 1, so 14 minus 8 is 6. I probably would have borrowed. By the way, want me to show my work? Absolutely. I'd love for you to show your work. It's a great idea. I'm going to borrow. 14 minus 8 is 6. 7 minus 1 is 6. But it's -66. And that would be my answer. Mr. V, that ain't too bad. No, it's not too bad this time. Wait for example number 2. That's the moneymaker. Because I'm going to say this. It is better to combine like terms first and then plug in x. So I've got stage 1, where I'm going to combine like terms. -3 times x plus 6 plus 8x. What does this equal? Balance line. I'm going to rewrite. Step 1 is always rewrite. Absolutely. Next step is distribute. In the parentheses, I'm just going to pull it apart. Got pulled apart. X went into one part, 6 into the other. Negative 3 went to both of them. Plus 8x. Negative 3 times x is just negative 3. Negative 3x. Negative 3 times positive 6 is negative 18. Right? Negative, and by the way, look, I was about to say negative 3 times 8x, but there's no negative 3 right there. It doesn't get a negative 3. He just comes on down, hangs out with his buddies. That's my distributing. Now I rearrange variables in the front, constants in the back. Still going strong. I'm at the point where I'm not going to anti-distribute. I'm going to say negative 3, because these are both x. Negative 3 plus 8 is positive 5. X. Plus negative 18, which I will rewrite, of course, as negative 18. Okay? Oh, sorry. That is so not right. It is 5x minus 18. Okay, so that's what I would do when I would be combining. Just making sure everything looks good. If you've been yelling at the computer screen for the past few seconds or minutes, and you'd be like, Mr. V, Mr. V, Mr. V, dude, 8 times 12 ain't, that ain't 84. That's negative 6, that's negative 96. You're right. And I'm glad you noticed that. Just gonna go back and fix this real quick. Gonna subtract again, just to make sure I got that right. Gotta borrow. 16 minus 8 is 6, or 8. 8 minus 1 is 7, so we got negative 78. Now I feel a lot better. So I was looking in the future, and I was like, that's not going to be right. And I'm glad I did that. Make sure you guys multiply correctly, please. And by the way, I've been showing a little scratch work right here. Okay. Now I'm on part 2. I'm going to plug in. Or, well, let's not call it plug-in. Let's actually call it what it is. It's substituting. So I'm substitute 5x minus 18. I'm going to go all the way back up here. Plugging in negative 12. 5 times negative 12 minus 18. 5 times negative 12 is negative 60 minus 18. Might as well change that into plus negative. I got 60 negatives. I got 18 negatives. Everybody's negative. Everyone gets along with each other. So we're going to be negative, and we're going to get stronger. We're going to build up our negative bank. And 0 plus 8 is 8. 6 plus 1 is 7. And check it out. Should be the same answer. That's how I checked myself, because I was looking at that. I was like, that's not going to work. It's going to be negative 78. Sure enough, I'm goofed up here. So if you caught that, good on you. Negative 78 and negative 78 is the answer. So there's two different ways of doing that. So you might be saying, why am I going to waste my time doing this? Well, that's a great answer. What if you got to plug in more than one value for x? What if x keeps changing the game? What if, for example, number 2, example, you had to take m, and m is going to change. M is going to equal 0, 1, and 2. You're going to be distributing, you're going to be doing craziness. It's best just to to simplify first and then plug in m. Because that's going to be a nightmare, plug in zeros, ones, and twos, because you have to do it 3 different times. If you're going to do it 3 different times, make it easy on yourself. Here we go. Step 1, I'm going to simplify this. Step 1, rewrite. I'm going to change that to plus negative. That's step 1, rewrite. Step 2, distribute. Negative 2, this is going to get pulled apart. Negative 2 is in front of both. But notice, negative 2 is in front of this one. 8 has got its own problems. 8 has something else inside of it. M and negative 4 go inside the ones of the 2. 3 and 2m go inside of that one. Okay. Let's multiply it out. Negative 2m. Negative times a negative is a positive. 8 times 3, 24. 8 times 2 is 16. M just comes and hangs out. He's cool. We just multiplied a constant. If it's a constant times the number in front of a variable, which is called a coefficient again, you just multiply them together. M doesn't change. It's just M. Okay, now I've distributed. Next step, rewrite. Sorry. Next step, rearrange. Negative 2m plus, well, that's m. That's a variable. Next variable, 16m plus 8 plus 24. Negative 2 plus 16, one's positive, one's negative. Negative has more voting power, or sorry, positive has more voting power, so positive will win. Negative 2 plus 16 is 14. M hasn't changed. M hasn't done anything. 8 plus 24 is 32. So we've gotten here. That's step 1. I've simplified the expression. Step 2 is actually plugging in different numbers. So for m equals 0, this is way easy now. Watch. 14m plus 32 is equal to 14 times whatever m is. Whatever m is, I can make that 0. I can make it 1. I can make it 2. So I'm going to make it 0 first. 14 times 0 is 0 plus 32, which is equal to 32. Done. Next, m equals 1. 14m plus 32 is equal to 14 times 1 plus 32. Again, I'm just plugging in for m, plugging 1 in for m. 14 times 1 is 14 plus 32. 4 plus 2 is 6. 1 plus 3 is 4. 46. Just going right on through. M equals 2. 14m plus 32. And I'm doing the exact same thing. I start by writing this. 14 parenthesis plus 32. What am I plugging in for m? Oh, 2. Order of operations. I multiply. Now I'm going to add. 2 plus 8 is 10. Carry to 1, 60. Done. Little thing to notice. What's 32 plus 14? 46. It's 46 plus 14. 60. That's something we call slope. We're going to talk about it in chapter 7. I love that chapter. It's graphing, pictures, love it. So, that's what look how easy that was. I didn't have to go through order of operation hell to get to the numbers. I simplified, yeah, that was a little rough, but I only had to do that one time. Look how fast I popped those out. So much easier. So that's a great use of combining like terms. Our last example is example number 3, and you're free. And we are done with combining like terms for this. We're done with combining like terms. And this one's the good one to end on, I think. Negative 3r plus 6r squared plus 5r plus 9r. And for me, this is the one that takes the cake. I'm going to rewrite. And you might be thinking to yourself, oh, well, negative 3 plus 6 is 3. 3 plus 5 is 8. 8 plus 9 is 17r squared. That's not going to work. I'm going to take a different color for the r's, and I'm going to use this is actually a different number. That variable, go all the way back to the first video, to the very first thing you wrote at the top of the page. Combining like terms, the variables have to be the same, and their power. That power is 2. These will have a power of 1. 1 is not equal to 2. They are not the same power. So we put the higher power actually in front. 6r squared goes in the front. Then everyone else goes behind them. Plus negative 3r plus 5r plus 9r. Notice the negative stayed with the 3. Don't leave it up here. Is equal to 6r squared. There are no other r squares. It's the only thing I underlined in green. He is by himself, or herself if you want to be equal opportunity. Negative 3 plus 5 is 2r. 2r. Not r square all of a sudden, just r. Plus 9r. 6r squared again comes down. He's hanging out by himself. One-man dance party. What the heck? 2 plus 9, because they're both r, they're both the same variable and the same power, is 11r. So combining like terms, I want to do this one last example because this can get tricky. That's done. I can't, the answer is not 17r squared. It's 6r squared plus 11r. I can't do anything else to simplify it unless I knew what r was. Okay. So that's basically combining like terms. 3 videos, lots of examples. I really hope this helps you out. And the next unit, the next section is on actually using combining like terms to solve equations. And I can't wait because for me, that brings it all together. So, see you next time.